So here are some interesting applications of total internal reflection. First, remember we talked at the start of this unit about reflection in mirrors, and we said in a real mirror the light reflects from the silvered back surface of the mirror. And I did mention that actually there are secondary images that are formed because the light also reflects a little bit at this surface, reflects most off the back and comes out here, refracts out, but some of it reflects. This light ray reflects at the back, comes back out and refracts out, a secondary image. But actually some of that light also reflects at the outer surface, goes back to the silver, comes back out, and so on. You get multiple images from a normal glass with a silver back mirror. If you don't believe me, go and have a look at your mirror. Have a look, see if you can see those extra reflections. You'll see them easiest when you're not looking straight on, but when you're looking at something at an angle. See if you can see them. What we'd like is to have a mirror that this doesn't happen in. And the only way we can do that is by avoiding this reflection at the outer surface. Well, we can do that if the light hits the surface at 90 degrees. Have a look at this. Light comes in here at 90 degrees, so it just refracts straight through. It hits the back surface of this prism at 45 degrees from the normal. But the critical angle for glass and for perspex is below that, it's about 42 degrees. So this light is totally internally reflected, a perfect single reflection of light. And when it gets to this surface, it's going at 90 degrees. It doesn't reflect. So what you get out here is a perfect reflection with no secondary images. Now we can use that, for example, in a periscope or in binoculars. So the light comes in here, reflects once, reflects again. These are very good mirrors without secondary images, and you see very well what's happening out there. Binoculars, they need to move them apart so that you can have larger objective lenses than would fit right in front of your eyes. So what they do is they shift the light out using prisms rather than using what we would think of as a normal mirror. Again, because it avoids secondary images. Clever trick, huh? Here's another application, a very major application in today's world. Optic fibre. The light that travels, let me go back a step. We want to send signals, information signals, computer signals, as light, because light can be used to store a lot of information, and it travels very fast at the speed of light. But we want to have it in some kind of cable, and while we can put electrons in a cable and bend around, how can I send light in a cable and have it bend around corners and not have to worry about it? What we do is we put it inside a glass fibre. So the light, when it comes to the edge of the glass fibre, provided the glass isn't bent too much, now you have to bend it a lot. If it's bent only a little bit, the light will hit that surface well away from the normal, far bigger than the critical angle. So it will simply reflect, no loss at all. Comes to the next surface, well away from the critical angle, well away from the normal, much in excess of the critical angle. So it just reflects. And on, all the way to the other end. And none of this light comes out the side of the optic fibre. Total internal reflection. Now there's one more very interesting application of total internal reflection, and that's a mirage. We talked once before about the air, and when we talked about sunrise and sunset, and we said the air at the top is actually thinner than the air at the bottom. But what happens on a hot day, particularly over desert sand or over the bitumen on a road, the stones in a road, the road gets very hot from the sun. And so the air that's close to the road, air that's close to the ground, actually heats up and becomes less dense. and this changes the optical properties. So as the light comes in and it gets to the warm air just above the surface, it actually starts bending away from the normal. And at a certain point, as it approaches the ground, it actually bends so far away from the normal that it cannot refract and continue downwards. It actually bends upwards. It reflects off the hot air into your eyes. And again, it's a virtual image. What you see on the ground is actually a reflection of the sky. Here's a photo that shows it clearly. This truck looks like it's driving on thin air, in mid-air, because what we see here is a reflection of the sky. The light coming from up here, from the sky above, is totally internally reflected in the hot air just above the road. And so when you look, you see the road, the sky, the truck, and then the sky. And that's a mirage.